All right, you should have tried the example problem on 910. If you haven't done that yet, we need to have a conversation. No, actually, you should try it. I will point out that the graph was incorrect, and so the graph should actually look like this. If you're careful, you'll have this is x plus 2 here in red, y equals x squared in blue, and then the area between them yellow and rotating around the x-axis, okay? And so try out that problem. Again, the graph is weird because it's the parabola doesn't go through 0, 0. It should. It's just like the whole thing shifted up to. We don't want to deal with that. We just want to deal with the fact it's like this. So try that problem out, and once you're done, hit pause, and then once you're done, hit unpause, and we'll get started. All right. So what's different about this situation? What's different about this situation is if you think about this, when I rotate this around the axis, okay, uh, the line becomes this thing down here becomes a cone with a top chopped off, right? And so that's true, but the problem is by cutting it with the blue means that there is an inside hole inside of this red, right? So ultimately you end up with this kind of a, see this blue one down here is this cutout, okay? Means that you're going to end up with a cutout zone. Let's see if I can do this with the, you're going to end up with a little cutout zone. And that cutout zone means that this area here is going to be hollow. Okay, so let me see if I can try that a different way. Some people got this right away. I understand. I'm going to be a little pedantic, but everybody else, I need to show it to you one more time. So this is roughly what you're looking at graph-wise. Is that right? Does it look like this to you guys? It looks like this to you guys. Okay. Oops, I'm backwards, reverse Polish, trying to do as best I can. Okay, so here's what the graph looks like. So if I were to rotate this, let me back it up a little bit so you get a chance to see it rotating. If I were to rotate it, it would swing down like this, right? And so as it's rotating, oh, that's terrible. Okay, let's pin one spot. Here's the spot I'm pinning. Okay, so as it rotates around and up, there's going to be a gap. There's going to be a gap right here underneath, right? And over here, there's a gap. You can't just use the outside curve because when this thing rotates around the axis, okay, this hole's going to form over here. Okay, this hole that is right here is going to form. Okay, there's a hollow spot. When I spin this around the axis, this part is missing. This little black area here that I'm going to shade in right here fast, this area here is going to be missing, right? There's going to be a big old empty spot there. Okay, so the problem, it initially looks like a daunting one. We're like, look at, well, wait a second, how am I going to figure out what the hole is? The answer is you're going to do it just like you did area, right? You're going to do the outside or this red shape, and then you're going to subtract out the blue shape, which is the hole. Okay? So you end up going, aha, I can do this. It's not really a problem. If I'm rotating, my rotating formula is going to be pi integral the radius in the x direction squared dx minus the whole part. Okay? Now, in this case, the 2 points of intersection are -1 and 2 in terms of x. So I'm going to start at -1 and end at 2. -1 and end at 2. Okay? So now the only really tricky part is for some people, and I don't know why this is really tricky because I can't see it, so you're going to have to think really hard and help yourself out, is what's the outside, what's the inside? When I rotate, the thing that's farthest from the x-axis, if I'm rotating on the x-axis, is going to be the outside of my curve. That's going to be the first radius, or the outside radius. And then the one that's inside is actually what's making the hole, so that's the part I subtract. Okay, so the integral from -1 to 2, this becomes x plus 2 squared dx minus pi integral from -1 to 2. The inside one was x squared dx. The rest is just, you can combine it like we did in the previous ones, a reminder on that, but I'm not going to here because I don't want to do two things at the same time. Gets a little confusing. This should be a 4x, sorry, dx minus, and then pi, and then -1 to 2, x to the 4th dx. Okay, bringing it home. I got x to the 3rd over 3 plus 4x squared over 2 plus 4x minus I'm going to put the pull both pi's all the way out to the front. Minus x to the 5th over 5 from negative 1 to 2. Look at that. I combined it after, even after I said I was not going to do that. So I get 8/3. What I do, a pi out front. 8/3 plus 2/4 plus 8 minus 32/5 minus, I put in a negative 1, I get negative 1/3 plus 2, that doesn't work. Yeah, plus 2 minus 4 plus 1/5. All right. And then the rest, you just simply add it all up. So the bottom line is, the way this works is you're just going to take the outside 1 minus the inside 1. The official formula ends up looking like this. Outside 1 minus inside 1. Agreed?